Hi guys, welcome to another video, and in this video I take on myself to visualize Quicksort. The video is inspired from coding trend video in which he visualized Quicksort using JavaScript, but I'm going to do it using Pygames. And if you're interested in this video, watch it to the end and let's get started. So first we are going to create a Quicksort function, and I'm going to pass my list, the smallest element size, the index of the smallest element and the index of the largest element, which is n-1, and then I'm going to create a quicksort function. So if you don't know, quicksort works on the principle of divide and conquer. We partition the array, and for the left of that partition value and to the right of the partition value, we call the quicksort function again and again and again until the low and high value becomes equal. So we are going to have a if condition if low is greater than high, and until this condition is broken, we're going to recursively call this function again and again and again based on the pi value that we get, that is the partition value. So we're going to create a variable pi which is equal to partition, and in here we're going to pass our array, our low and our high, and then call our quicksort function for the right and the left to that pi value. So in partition we passing the list and low and high, and then we're going to create a quicksort function, and here we'll pass the left side of that pi value as the highest element, and then for our next quicksort function we are going to pass the lowest element to be one greater than that pi value and the high value. And in this way we are going to recursively call our quicksort function again and again and again until so let's create our partition function, and here I'm going to pass our list, our low and our high. So array low and high, and I'm also going to create a variable I which is going to be one less than the low variable. So I low minus 1, and then I'm gonna let's say create a pivot variable which is gonna hold the highest value of our list. So ARR high will be the biggest value for that particular uh, how should I say this, a particular gap. So from low to high, the biggest value will be, or the element at the last of that particular range is going to be pivot. And then I'm going to create an if condition. So let's say if our AR or J, that is the value of the element, is less than our particular partition, our particular pivot, then we're going to increment I, and we're going to swap the values. So if it works smoothly, and there is never a time that J is greater, ARR J is greater than the pivot, then I is less than 1 and we increment I, so I and J are at the same positions. So here, then at the end of our loop, I'm gonna return our I plus 1, which is gonna be the pi value, and before that I'm gonna have a swap value, and I'm gonna swap the pivot with the I plus 1. So if everything goes smoothly, I plus 1 will be the same value as high, and it's not gonna make a difference. But if it's not, then we are gonna have to swap the elements, and that should be swapped because that I plus 1 will hold a value bigger than the pivot value. So let's see an example here. Let's dry run this code. So we have 10, 7, 8, 9, 1 and 5, and for starter I should be less than the 0 value, so I will be at the -1, and this is our low, which is going to be 10, and high is going to be 5, and we're going to call the partition function here. And for starters, I is before 10. Here there should not be anything like -1, there's no block, it's just a depiction here for visual purposes. So ARRJ should be less than PIVOT. Pivot value is here is 5, but we can see that's not the case. So we are not going to increment I, and J will be increment to 2, and I is -1 at the, J is going to increment to 1. J is 0 at first, then it's going to be 1, and I is still -1. Then we are not calling our swap function, and we are just skipping back to the for loop, and next time 7 is also not less than 5, so we are again shifting to 8, then 9 and then 1. So here this is the first time that we're going to use this code. We're going to increment I to +1, and then we are going to swap the 1 and the 10 values. So here 1 and 10 will be swapped. and I value is incremented to 1 this time. And then this particular loop end, and we will swap the highest and the lowest value. So I was at the 7th position, and that's why we should swap 7 and 5 here, and that's what our last line of the code depicts. So I plus 1 and high will be swapped, and you can see we have somewhat of a bit sorted array in the first. And notice and remember that it is a recursion, and we're going to solve it for the smaller values after the first one is solved for left and right of that pi value, and that pi value is at 5. So now we are going to solve at the left and the right of the particular value. So this is how divide and conquer works. We divide a list and then we try to conquer it by solving it, and or I should say by sorting it. So this is the code for our quicksort, and now we need to visualize it. So I should just move it upwards, our list and the length. So let's copy it, and I'm gonna create a function called main function. As you know, I usually do this, and then call main function from the driver's code. And here I'm gonna create a run which is gonna be true, because we cannot run our window unless we have a true while loop. Yeah, we can we have to create that cross button. So for starters, let's create pygame.init, pygame.initialize, and so let's have x and y positions for our boxes that we're going to draw. So x is equal to 40 and y is equal to 40, and I'm also setting the width here to be 20 here, which is going to be uniform throughout our boxes, and these boxes are going to represent the height of this array so for visualizing. So I'm going to create a draw function, and here I will pass the array, and let's draw the window pygame.display.set mode and 700 cross 700. So the window size is 700 and 700, and in the draw function I'm gonna create let's say I'm gonna fill the window, and for filling the window I need to have a tuple of 0 0 and 0 that represent black color. Next let's create a for loop for I in range the length of my array, and here I'm going to create rectangles. So pygame.draw.rect, and I'm going to pass my window and also the position of, and also the color, which is red, so 255 0 0, which represent red color, and the position x and y, and height and width of my rectangle. And height as well as the position of my rectangle will be changed depending on the I value. So I'm going to multiply x with 5 30, and so what I can do is x plus 10 into I, and then I can do is error into 5. So I can have x position changed depending on the I value, and for our array I can multiply it by 5 to so that I can see it on the screen, because values like 2 4 and 5 will be very small to look at. That's why I'm multiplying it by 5. And let's call.tick, and here I'm going to have 30 here. Here I'm going to create for event in pygame.event.get. For closing my window I have to set event.type is equal to pygame.quit, and run is equal to false, and in this way I can close my window. So this is important. And also I have to find a way to look to pass this let's say keys is equal to pygame.key.get pressed. So, and this is will be helpful when I'm pressing my spacebar. So I need keys here, and also I need a variable execution which is false at first, and if execution is equal to true, hey, wait a minute, I think I made a mistake here. So what I need is if keys is pygame.k space, whenever I press the space bar I should have the variable is true. Now the execution is true, and if execution is true I'll start my quicksort function, and if it's false then it's just window.fill is black, and I'm going to call the draw function here, and pygame.display.update here as well. Also I need to call my draw function in my partition function as well. So here after the for loop is ended I'll call my draw function here, and also after the left quicksort is ended. Okay, let's now come to else condition, and if execution is true I have pressed the space bar, then I will just call my quicksort function. And also, so what I have to do is now I think the code is not complete, and I should just Okay, so I forget to import my um, pygame as well as the time. So import time, and I think it should work now. So let's call it. And okay, so we have forget to pass the array function in my quicksort value. Okay, so if just done and process. Okay, it's way too fast. You cannot see it. I think what I should do is I think I should just create. I should just move the clock downward after the display dot update. I think that will work. So let's switch cloud dot tick after pygame display dot update, and also a new window variable. So now if I rerun my code, I think it should work. So let's I always forget to close the window, so let's close it and rerun it. And if I press the spacebar, I think it should work. Just take some time. Let's press it again. Okay, so now we can sort of see it visualize. I think I should just slow down my clock function a bit. And what I need to do is, let's see if I comment my clock, if it will how fast will it be. So let's get a terminal, and that's way too fast. And so guys, if you like this video, consider subscribing, and I hope I see you in my next video. Thanks for watching.